Welcome back to physics, and today we are going to talk about circular motion.
And maybe hit somebody with a stopper.
So we have a crazy physics teacher in this room right now, only one, and he is swinging a 0.5 kilogram stopper on a 1 meter string, but he's too close to the board to actually do it at 1 meter.
Yes, that's true. I actually don't even know the length of the string. It's probably more than 1 meter, but I'll swing it a little shorter than that just so I don't hit the board.
Yeah, that's what you're trying to avoid hitting. And it is being swung at a velocity of 2 meters per second by our crazy physics teacher. And our goal is to find our centripetal acceleration and our centripetal force.
For this particular demonstration, I will swing it this way over my head because when we swing it the other way, don't hit myself, when I swing it the other way, there's other forces involved. So we don't want to actually have to calculate those other forces. For this one, we're just going to swing it this way. Now, the centripetal force is being supplied by the string. Remember, centripetal force has to be directed towards the center, and the only thing that's pulling that stopper back towards the center is the string. So we got to find two different things here. We got to find F sub c, which is centripetal force, and A sub c, which is centripetal acceleration.
So, just like any other physics problem, we would start by writing out all of our givens. So as I'm going through this problem, I see a 0.5 kilogram stopper, so that is my mass, on a 1 meter string. So if he's swinging that string around and it's 1 meter long, that's going to be the radius of my circle. So we have to remember some of those geometry words now.
Now, the radius is really just a distance between the centers. That would be the distance between the center of the circle and the distance, the distance between the center of the circle and the center of the stopper. Now, that is a radius, even though it's really a distance from here to here. As it's swinging, if we could freeze it in a moment of time, it is a distance, but it's really a radius because that stopper is swinging around that center of the circle and would always be at that distance. The only way I can get the distance to increase is if I let out more string, and I can get the distance to decrease by pulling some more string back. But we're saying for this problem that the distance is going to remain the same of 1 meter.
And then as I keep reading through it, I see at a constant velocity of 2 meters per second. That's a V, like a normal V.
Just my hand slipped. Anyway.
We're trying to find our centripetal acceleration and our centripetal force. So we'll start with centripetal acceleration, and when you go back to the back of your reference table, you will see, getting near the bottom of that back page now, that we have a formula that says A sub c equals v squared over r.
Nothing fancy there. Just take your velocity, square it, and divide it by r. Now, we gave a good, nice r to use because you should divide it by 1. 2 squared divided by 1 is just 4. Now, what about units? Well, it's an acceleration, so it should have the same units as everything else that we ever done for acceleration. But if you want to check, this would be meters squared over seconds squared divided by meters, which would just leave you meters over seconds squared.
Okay, so nothing crazy. Just make sure you are remembering to square that velocity. It's not just attached to the units, it is attached to that entire number, so be careful of that.
This is a common Regents question. And the most common mistake here is two of them. First one is that they forget to square. Second one is that people will put it over 2 meters. Now, where's the 2 meters come from? It comes from the fact that people start to think this out and they think, well, this is 1 meter and there's another 1 meter, so the distance would be 2 meters. Well, that's not true. Like we just talked about, this distance, this r that you're using, is the radius of the circle, which in this case is just the length of the string.
And then the next part of our question is asking us to find our centripetal acceleration. So again, the back of your reference table.
Centripetal force.
Sorry, centripetal force. We just found centripetal acceleration.
Yep.
Back of your reference table, we have Fc equals MAC. Now that formula should look pretty familiar to you because it is very similar to our Fnet formula, which is Fnet equals Ma.
Every single force in the world can be set equal to some mass times some acceleration. So just because we're saying centripetal force does not mean we change the way we find the force. It's still a mass times an acceleration. But if we're finding centripetal force, the acceleration you're talking about is the centripetal acceleration.
So I'm going to plug in my 0.5 kilograms and my 4 meters per second squared, and I end up with a centripetal force of 2 newtons.
It means it takes 2 newtons to keep this stopper moving in that circular motion. Then the question becomes, what actually supplies that 2 newtons of force? Well, the only thing that I have attached to the stopper is the string. So that 2 newtons of force comes from the string. If I was to attach a spring scale to this system somehow and figure out a way to read it, it would read 2 newtons. Now, the question becomes, what happens if I start swinging faster? Well, if I start swinging faster, V is going to increase.
So let's say that we double the speed that we are swinging it at. So instead of 2 meters per second squared, I now have 4 meters per second, and I'm squaring that. So that is going to become an acceleration of 16 meters per second squared.
So notice that because we doubled our velocity, the acceleration did not double. It quadrupled. Why? Because this velocity on top is squared, and 2 squared is 4.
So if we double our velocity, we're getting 4 times that centripetal acceleration.
But then what happens to the force? Well, this acceleration went up 4 times. And that formula is straight m times ac, which means your force goes up 4 times. 2 times 4 is 8. Finally, the last question could be, well, what happens if I started swinging it so fast that the force that the string needed to provide is more than the tensile strength of the string, meaning that it can't hold that much force? What happens then? Well, the string will break, and your stopper will go flying across the room, and hopefully not hit the camera or the person sitting next to you.
So we are going to be doing a lab with this tomorrow. So it can get dangerous if you are not careful of what's going on around you. So please be aware of your surroundings.
Just from past history, people have gotten hit in the back of the head, people have gotten hit in the face, in the back. People get hit all the time in this lab. So we do have a face shield if you want to wear one of those, and maybe some kind of body armor we can find for you also.
If you want to bring something in, feel free.
Yep.
We can make it work.
Captain America shield.
But just be aware of your surroundings tomorrow as we go through that. And if you have any questions, please ask. You are going to have a quiz on all of this on Thursday.
Remember, just like every other topic, it starts easy, but it doesn't stay that way. So, that being said, come to Extra Help, and have a great night.